All right, welcome to today's Explainer. I am so excited to have you here because today we are tackling a massive headache for 5G network engineers. Look, if you work with a network data analytics function, or NWAF for short, you already know the pain point I'm talking about. It detects anomalies in your 5G core, it fires off an alert, and then, well, it just stops. It leaves your human analyst to manually dig through subscriber profiles, frantically search fraud runbooks, and write up root causes completely from scratch. It's repetitive, it burns through expert time, and frankly, it just doesn't scale. But today, we are going to solve that problem by bringing in a completely automated AI-driven investigator.
Okay, let's dive right into this. Here is our roadmap for today. 1. The NWDAF problem. 2. Demystifying the AI. 3. Autonomous investigation. 4. The 4-layer architecture. And 5. Validation and human expertise.
Starting off with Section 1, the NWDAF problem, alerts without answers.
Let's step into the reality of the 3GPP standards for a second. Per the spec, when NWDAF detects abnormal UE behavior, the output gives you the affected SUPI, an anomaly label like, say, unexpected large rate flow, a confidence score, and a time window. And honestly, this brilliantly illustrates the glaring gap in our current operations. You get an alert and a confidence score, but absolutely zero root cause. There's no subscriber context, no fraud match, no recommended action. It is literally just a signal that something is wrong somewhere, and the heavy lifting of figuring out why is left entirely on the shoulders of your human analysts.
Moving right along to Section 2, demystifying the AI, from search to autonomy.
So to automate this totally unscalable manual process, we need to quickly define 3 core technologies that build on top of each other. First up, we have the LLM, or Large Language Model. Think of tools like ChatGPT or Google Gemini. You don't build this from scratch, you just rent access to it via an API, exactly like how one 5G network function calls another over HTTP/2. The LLM acts as the AI brain. But here's the catch, and it's a huge one. While an LLM is incredibly powerful at understanding language, it is completely blind to your internal network logic. It couldn't tell your specific fraud patterns or a particular subscriber's data usage from a recipe for chocolate chip cookies. It only knows its original training data, meaning it definitely cannot solve your NWAF alerts on its own.
And that leads us to RAG, or Retrieval-Augmented Generation. RAG basically solves the LLM's knowledge problem by acting like an open book exam. Instead of the AI just guessing from its training memory, the RAG system searches your specific operational data first, like your internal fraud runbooks, and then it feeds that highly specific, relevant text over to the LLM so it can answer accurately. It is a massive leap forward. But to be perfectly honest, on its own, it's still just a really smart search box.
Which brings us to the real game changer, Agentic RAG. Normal RAG answers one fixed question that you have to manually type in based on one single source. Agentic RAG, however, provides true autonomy. It acts exactly like a junior analyst on your team. It receives the NWDAF alert automatically, decides entirely on its own what needs to be looked up, queries multiple different systems in sequence, checks its own work, and then synthesizes a complete root cause analysis. This is the exact autonomy we need to handle network alerts without any human prompting.
Section 3. Autonomous investigation, tracing and alert.
Let's look at a concrete, technical example of how this actually plays out for a specific SUPI in the wild. Imagine the agent receives the alert. It doesn't stop and ask a human what to do. It just begins its investigation autonomously. Step 1. The agent independently queries the BSS, or Business Support System, API. It asks for the contracted service type. The BSS replies, "Hey, this SUPI is a low-volume IoT SIM with a 500 megabyte monthly allowance." Step 2. The agent immediately pivots and queries the CHF, the charging function, or OCS API, to check real-time session usage. The response? Boom! This SUPI just transferred 4 gigabytes in the last 10 minutes. Step 3. The agent realizes this is highly abnormal and automatically searches your internal fraud signature store, finding that this exact pattern perfectly matches unauthorized SIMbox data relay. This brilliantly illustrates the absolute power of this system. The agent took 3 completely disparate API calls and synthesized them into a highly actionable root cause analysis in literally just minutes. It contextualizes that 4 gigabyte transfer against the 500 megabyte cap, flags the SIMbox fraud signature, and recommends terminating the PDU session. Guys, an investigation that normally takes an engineer 20 minutes of manual digging is completely finished before you even open the ticket.
All right, Section 4. The 4-layer architecture, system teardown. Now that we've seen it in action, let's physically tear down the architecture. Think of this like an assembly line, where each layer has one very specific job. Layer 1 is your NWDAF. It does what it always does. It monitors the 5G core and rings the alarm bell by firing off a notification. Layer 2 is the trigger. It's just a simple Python webhook, always listening up on the cloud, which opens the door and passes that alarm over to the agent. Layer 3 is our investigator. This is where LangChain, the LLM, and your custom data tools all work together to build the root cause. And finally, Layer 4 is the output, seamlessly dropping that completed investigation into whatever system your network operations center already uses, like Jira or Grafana, ready for human review.
Let's zoom in on Layer 3 for a second, because this is where the magic really happens. LangChain acts as the office manager. It coordinates this continuous loop between the AI brain, let's say Google's Gemini, and your Python tools that query the BSS or CHF. The LLM might say, hey, call the BSS tool. LangChain runs it, gets the 500 megabyte allowance, and feeds it right back. Then the LLM says, okay, now call the CHF tool. So the absolute crucial point here is that you, the engineer, define what tools actually exist, but the LLM decides the order in which to use them based entirely on the data it uncovers along the way.
And finally, Section 5, Validation and Human Expertise.
Look, if you're a telecom engineer, it is completely natural to have some serious skepticism about letting AI loose on your live network. And the most important question you can ask right now is, how do you know if the agent is answering incorrectly? Because if left unchecked, AI mistakes can severely disrupt network operations. There are two main failure modes we have to constantly watch out for here. First is wrong retrieval, where the agent pulls a totally irrelevant record from a tool and confidently hands you the wrong answer. The second is hallucination, where the agent finds the right record, but the LLM just invents extra details from its training memory that simply aren't in your source data at all. So, to catch these errors automatically and at scale, we use an amazing open-source evaluation framework called RAGAS. RAGAS scores the system on 3 key metrics. Faithfulness. Does the final answer actually match the retrieved data without hallucinating? Answer relevancy. Did it address the specific NWDF alert we gave it? And context precision. Did it retrieve the right data from your BSS and CHF in the first place? Simply put, if an AI answer cannot show you exactly which source record it used to get its conclusion, you just don't trust it.
And that leads us to our core takeaway for today. The AI handles the execution and the reasoning, absolutely, but you handle the domain design. Human domain expertise is utterly irreplaceable here. The agent is only ever as good as the tools it is given. Knowing that the BSS holds the service profile, that the CHF holds real-time session usage, and knowing exactly what a Symbox signature looks like, that is pure telecom domain knowledge. No generic AI engineer has that. The AI relies entirely on you to design the right tools and to perform expert spot checks on its outputs.
We've covered a massive shift today in how we handle network anomalies, moving from basic, contextless alerts to fully autonomous, multi-system root cause analysis. By combining NWDAF's detection with Agentic RAG's investigation, we can literally save countless hours of manual work without sacrificing 1 ounce of expert oversight. So I will leave you with this final thought to ponder. Are you ready to let Agentic RAG investigate your next NWDAF alert? Thank you so much for joining me for this explainer, and I really hope this gives you a powerful new perspective on automating your 5G network operations.